Polymorphism. Polymorphism manifests itself in Java in the form of multiple methods having the same name. Polymorphism is classified into two types, static and dynamic, or also called as compile time and runtime. Static or compile time polymorphism. Static or compile time polymorphism implies that the decision about which method to execute is made at compile time. Static polymorphism can be achieved by using overloading. Overloaded methods. Overloaded methods can appear in the same or subclasses. Overloaded methods have the same name. Overloaded methods have different parameter lists. Overloaded methods can have different return types. Overloaded methods can be implemented in subclasses. Let's see an example. Here is an example of static polymorphism. As discussed in the previous slide, static polymorphism implies same method name. As you see here, we have the same name for the method. Different parameter list. Here is a method with no arguments. Further, you have a method with two integer arguments. And then you have a method with two float arguments. And then with two string arguments, which implies different parameters. Static polymorphism may have different return types. However, return type is not important for polymorphism. Now let's talk a little about soccer. A soccer player kicks the ball in multiple ways, such as drop kick, goal kick, and front tackle kick. A few common behaviors of a soccer player: run, kick, position, interception, and so on. Let's elaborate a little on the kick. Here are a few important types of kicks that a soccer player can perform. Too many names to remember for a programmer. Here is a polymorphism version. For polymorphism to be implemented, it is mandatory to have a different signature. Now let's consider an example. This part of the method's prototype is considered as signature. However, the return type is not a part of the signature of the method. As discussed earlier, the signature of the method has to be different in order to implement polymorphism. As you see here, the signature of all the methods for add is different. Methods can be static or non-static, but they should have different signatures. Overloaded methods may call one another simply by providing a normal method call with an appropriately formed argument list. Overloading a base class method in a derived class does not hide the base class versions. Dynamic polymorphism. In this type of polymorphism, the decision about which method to execute is made at the runtime. This can be achieved by using method overriding. Overriding occurs between multiple methods having same name, same signature in different classes in a class hierarchy. Overriding can be implemented in two ways. Overriding through inheritance. Overriding through interfaces. Let's see an example. Let's go back to soccer. Here I am extending goalkeeper and striker from soccer player. As discussed in the previous slide, dynamic polymorphism is possible only between base and derived classes. Consider soccer game. The way the position of the ball is taken differs from player to player, such as goalkeeper and striker. This implies that the position method of goalkeeper would be different because he can use his hands too. Hence, the child class goalkeeper would override the position method of parent class soccer player. Now let's look at an example. In this example, I will demonstrate you both overloading and overriding with inheritance concept. In the previous example, we have seen how to overload methods in the same class. In this example, I have two classes, soccer player and goalkeeper. Class goalkeeper extends soccer player. In soccer player, I have two methods, kick and position. Let's first talk about the position method. As discussed in the previous slide, I need to maintain the same signature in both parent and child classes in order to implement dynamic polymorphism or method overriding. As you see here, I have the same signature in soccer player as well as inside the goalkeeper class. That means goalkeeper implements the same behavior of taking position in a different manner. Method overriding occurs when a child or a derived class needs a different version of implementation of the base class methods. In order to implement dynamic polymorphism, the child class needs to have the same signature of that of the parent. Now let's look at the other method, kick. If you have noticed here, the signature of the method kick differs from parent to child. That is, the child has a different parameter list to this method. In such a case, it is considered method overloading. Though it occurs between a parent and a child class, it does not hide the parent version or the parent implementation of the kick method. Thus, you can conclude that in order to implement method overriding, the signature of the methods between the parent and the child classes needs to be the same. However, the signature differs in case of method overloading, as you see here for void kick, string free kick, and void kick, string drop kick, int height. Here is another example. Soccer player has certain generic behaviors for all soccer players, irrespective of what player type he is. However, the different soccer players might have specific behaviors, such as the kick implementation for a goalkeeper would be different from the kick implementation of the striker and so of the defender. As you see here, the soccer player implements two kick methods, free kick and corner kick, which are common for all players. However, the goalkeeper has another version of kick which is specific, wherein it's a drop kick. And then you have the striker who has a goal kick and defender having a front tackle kick. Here the implementations of these kicks is different. Therefore, they are method overridden. Variables can also be overridden. It's known as shadowing or hiding. This implies that I can have a variable with the same name in both parent and derived class, or base and derived class. However, the derived class shadows or hides the parent version of the variable. Subclasses can use super keyword to access the shadowed variable in superclasses. This means that I can always refer to the parent version of the variable using super.parent version of the variable name. This can be used in the derived class. Private methods are not overridden. As private methods are not available for the derived classes, they cannot be overridden. So, calls to private methods are resolved at compile time and not subjected to dynamic method lookup.